For years, the Thanh Hoa Bridge refused to die. American aircraft came at it again and again. Bombs fell, rockets fired. Pilots risked their lives over one of the most heavily defended targets in North Vietnam. And still, the bridge stood. That was why it became a symbol. To North Vietnam, it was proof that steel, concrete, air defenses, and geography could protect a vital supply route. To the Americans, it became a problem that would not go away. The bridge had a nickname, the Dragon's Jaw. It crossed the Song Ma River and carried rail and road traffic through a critical part of the North Vietnamese logistics network. Supplies could move across it. Military equipment could pass over it. The war could keep feeding itself across that span. Destroying it should have been simple. Find the bridge, drop bombs, break the structure. But that was the trap. A bridge is not one target. It is many targets pretending to be one. There is the deck, the rails, the road surface, the truss, the piers, the joints, the approaches, the load paths that actually carry weight. Hit the wrong part, and you make smoke. Hit the right part, and the structure starts to fail. For years, the problem was not that American pilots could not find the Dragon's Jaw. The problem was that finding a bridge is not the same as killing it. The air defenses around it made every attack expensive. Pilots had to fly through anti-aircraft fire, surface-to-air missile threats, and a sky designed to punish straight, predictable runs. The bridge sat inside a defensive environment where aircraft could not simply take their time, lining up a perfect shot. Speed kept pilots alive, but speed made accuracy harder. Altitude could protect aircraft, but altitude made unguided bombs less precise. Low-level attacks could improve aim, but low-level attacks put aircraft closer to guns. The bridge did not survive because it was magic. It survived because killing it required a level of precision that the attack system had not yet fully delivered. That is the important part. Many bombs could damage the bridge, but damage is not death. A crater on the approach can be repaired. A twisted rail can be replaced. A damaged deck can be patched. Even a partial hit on the structure can leave enough of the span usable, or at least repairable. The Dragon's Jaw was not invulnerable. It was resilient, and resilience is different. Resilience means the defender does not need to stop every bomb. He only needs the target to survive enough to be fixed. Every failed strike taught the defenders something: where to place guns, how to repair damage, how quickly crews could restore movement, how much punishment the bridge could take before the logistics route truly stopped. That created the safety assumption. The bridge could be hit, but it could not be reliably killed. Then, precision changed the equation. By the early 1970s, American air power was entering a different era. Laser-guided bombs turned the problem from area bombing into point attack. Instead of dropping iron and hoping the geometry worked, aircraft could guide a bomb toward a specific spot. That mattered for a bridge, because the target was not the whole span. The target was the weak point in the span, the part where force traveled, the part where one accurate hit could do more than dozens of near misses. Precision did not make the bomb stronger, it made the bridge smaller. Now the mission changed. Pilots no longer had to simply attack the Dragon's Jaw. They had to dissect it. Where does the load move? Where does the structure depend on a key connection? Where can one hit cause the greatest failure? That is the difference between bombing a target and breaking a system. The bridge was the system. The weak point was the path that held it together. The attacking aircraft came in, knowing the defenses were still alive. This was not a clean laboratory test. The sky around the bridge was still dangerous. North Vietnamese gunners still understood the value of the target. The bridge still sat under protection, and every aircraft approaching it had to survive long enough to release or guide the weapon. The pilots had to manage the run-in. Find the target. Hold the right geometry. Keep the laser on the aim point. Avoid being forced off the attack by enemy fire, and trust that this time the bomb would not simply make another scar. It would find the point that mattered. The bridge appeared ahead, a long steel shape across the river. Familiar, defiant, surrounded by the memory of failed attacks. But the attack profile was different now. The bomb was no longer just falling toward the bridge. It was being guided. The laser energy marked the aim point. The weapon's seeker followed the reflection. Small corrections changed its path, pulling the bomb toward a spot that a traditional attack might only hit by luck. The defenders could still fire, but they could not move the bridge. The bomb came down, not somewhere near the river, not somewhere close enough to make smoke, onto the structure. The hit landed where precision mattered, driving explosive force into the part of the bridge that carried the load. For a moment, the Dragon's Jaw was no longer a symbol. It was engineering under attack. Steel bent. Connections failed. The span lost the shape that made it useful. That is how bridges die. Not always in one cinematic collapse. Not always by vanishing into the river in a single fireball. A bridge dies when the load path breaks, when the deck can no longer carry traffic, when the structure can no longer be trusted, when the repair problem becomes larger than the movement it was supposed to support. The Dragon's Jaw had survived years of punishment, but precision turned punishment into failure. That was the shift. Earlier attacks had treated the bridge as a large object. Precision attacks treated it as a machine with stress points, joints, supports, and load-bearing elements. Once air power could hit those points, the defender's repair advantage weakened. Instead of patching superficial damage, crews now faced structural destruction at the exact places that mattered. The bridge was not just hit, it was disabled as a logistics artery. The strategic lesson was bigger than Thanh. Wars are full of targets that look too strong for normal attack. Bridges, tunnels, bunkers, ships, airfields, radar sites, command nodes. But a strong target is rarely strong everywhere. It has a throat, a hinge, a joint, a sensor, a pipe, a pier. A piece of the system that quietly carries the weight of everything else. Precision warfare is the art of finding that piece and making the whole system pay for it. That is why the Dragon's Jaw matters. It was not simply a bridge destroyed in Vietnam. It was a demonstration that the age of near misses was ending. A target could survive hundreds of bombs if the bombs arrived in the wrong places. Then one guided weapon could change the story by arriving in the right one. North Vietnam thought the bridge could endure. The guns were there. The river was there. The repair crews were ready. The steel had already survived more than enough to earn its legend. Then precision found the weak point, and the Dragon's Jaw finally broke. If you want more hard breakdowns of military operations, hidden weak points, and the moments that changed modern warfare, follow the channel and check the homepage for more stories. Thanks for watching. We'll see you on the next battlefield.